Okay, so for our last talk of our session today, we have Arno Schots, who's a Cloud Solution Engineering Director at Oracle, and also one of the co-organizers of Jay on the Beach. And we also have Juan Rico, who is a Cloud Solutions Architect at Oracle. So Arno, aside from his day job, is an enthusiastic sports person. I see him running a lot actually around Malaga, and he spends as much time as possible trail running, cycling, and windsurfing. And Juan Carlos just became a father for the second time. Congratulations, by the way. So he's spending a lot of his extra time on diapers and milk bottles when he's not engaging with customers, right, Juan Carlos?
That's correct.
All right.
Funny times.
So if you guys are ready, I'm going to let you share your screen and take it on.
That's fine. Just give me a shout if you can see my screen, the presentation mode.
Yes, we can.
Excellent. Okay, so let's get started for this last session of today, and welcome to this topic. So it's a very exciting area in the IT industry, I would say. And thank you, Alexandra, for the introductions. So we've included a short bio here as well in the presentation, since it's recorded, and probably the slides will be shared as well. So as I said, yeah, we only have 30 minutes, but we could be talking about this topic for weeks and for days actually. So as we said in the invite and in the publication on the website, in our daily job as architects in Oracle, we work with many customers. We see a lot of companies around the globe moving data and workloads to the cloud. So that's probably not a surprise. But what we see more and more as well is let's say companies adopting a multi-cloud strategy, right? So they're not only using Amazon, but they're starting to use combinations of cloud providers. So that will be the topic of this presentation. You will learn about, okay, what are the drivers for these companies to go there? Why should you care? How you can implement a multi-cloud strategy successfully. And we brought some real world architectures to share with you, so you get an idea, and we talk a little bit about the tools that we see out there in the field. So, of course, this introduction is not intended to be complete. So that being said, Juan Carlos, maybe you can tell us a little bit about what we understand.
That's it. Thanks, Arno, and thanks, Alexandra, as well for the introductions. That's it. As we mentioned before, if maybe this is a buzzy word, the first thing when I see a buzzy word that I don't really understand is to Google it. And maybe that Google search forwards me to a Wikipedia introduction. So taking it from the Wikipedia, multi-cloud means like the usage of different services from different cloud providers and cloud vendors as a single unit to serve a business purpose. And that makes sense for our common sense, we could say. But it's true that most of us are developers or engineers. So many questions could arise from this buzzword. How does it look like a multi-cloud implementation? What benefits can a company get from it? Or how do I know if that multi-cloud strategy helps my company in this specific scenario? So those benefits plus those real-world examples that Arno mentioned in the previous slide will be explained later in this presentation. But starting from the very beginning, this kind of architecture style is not new of the cloud era, right, Arno?
Yeah, that's correct, Juan Carlos. So a bit of history. So 10 years ago, I was building new data centers for ING investment management. We were operating around the globe. And back then we were already discussing the ability to move workloads and data in a follow the sun principle, right? So because we were in the trading business, so latency and being close to stock exchange is super important. And we wanted to run applications and provide them to our traders, in, let's say, for example, in the European time zone. But once the stock markets closed there, we wanted to move them to the United States, right? So our traders in the States would be close to the data. So we talked about moving data and workloads back then, which is a concept of multi-cloud. Back then it was more a vision. Now it's really a reality. So if, for example, if we look at one of the architecture concepts that we had back then, right, you immediately recognize this as to be some kind of blueprint for a modern cloud platform, right, with the core infrastructure in the middle, and things like orchestration, provisioning, metering, billing, right? So that's what we try to achieve. Also in the area of storage, right? I was really hoping to be able to provide storage as a service that you could change according to your needs during the day. Back then, it was really complicated to achieve, but for example, nowadays in Oracle Cloud, you can just switch between high performance storage and economic storage real time, right, without even downtime. So just imagine how far we have come in 10 years in the cloud space, and basically everybody will agree that the cloud market is here to stay, right? It is maturing still, but it has already matured for many years now. And basically, we see a couple of big players. We call them hyperscale cloud providers, right? Like Amazon, Google, Microsoft, Oracle, right? Well-known names. And we also see a big playing field of more specialized players like Linode and DigitalOcean, who have a much more simple portfolio, but what they do really good, right? So the main question here is, when talking about multi-cloud, but cloud as well, as a non-IT company, why should you bother with building your infrastructure, right? With all the complexity that comes with it. So it's cloud is one thing, but multi-cloud is really the next step. So Juan Carlos, why should people care about multi-cloud strategy?
Sure. I mean, there are several benefits of going multi-cloud. The first one, it's really clear. If I'm able to adapt my workload to run on every cloud provider, I can avoid that vendor locking. That it's one of the biggest threats or biggest fear when we're picking a technology or a service provider to cover the business need we're looking for. There is also another impact or another point of view for a multi-cloud, which is from the software as a service perspective. We know that one size doesn't fit all. Because if you're acquiring a CRM, it is true that this CRM is trying to include new features for ERP, for HCM purposes, or for other business line of businesses. But those are really new. You probably, or your company probably acquired that specific piece of software for one specific purpose, which is really, really good. So if I'm able to integrate data from multiple software as a service vendors, I will be able also to choose what SaaS is better for the different needs that my company needs, without worrying the data is accurate or wrong. We're going to show later on one of the real world examples in this software as a service area. There's also another benefit, which is like if I'm able to integrate compute and storage service from different vendors, I can get the most from everything almost. Every vendor has a flagship. So if you think about Google Cloud Platform, you may think about AI services. If you think about Salesforce, you're going to think about their CRM. If you think about Oracle, you're going to have the database in mind. So despite the fact that most of cloud providers try to cover almost every need, nobody reached that point yet for every use case and for every technology. And that's a reality. So if I'm able to provide to my company the best of every cloud as a single unit, I can cover almost every business need with the best of every provider, which is pretty powerful. So even more, even in the on-premise world, you may use different technologies to solve business needs in a successful way. So why in the cloud that should be different? That makes perfect sense. There's also, we've seen in the field, another case for startups. Most of the startups, 90% of them, their main target or main objective is to be acquired by a larger company. But what if your startup has chosen a specific cloud vendor, but the parent company is using a different one? So for instance, you're as a startup are using Google's cloud, but then your parent's company is running Azure, Microsoft Azure. So instead of migrating all the instances or all the workloads you may be running, that could be tedious, a titanic effort for that specific, for your company. So instead of migrating, why don't you choose try to integrate both clouds? We're going to discuss that later on in this presentation as well. And there is also a third point or fourth point, which is the economics. Your workload may evolve over time, and also the different providers have evolved over time. So you may be interested in running your workload where it's cheaper at that moment in time. Okay, Arno was going to show you some figures, right, about this topic.
Yeah, just to in the multi-cloud world, right? We think that one of the main objectives also for organizations will be is to see where can I run this workload in the most economic way, and just to give you an idea of why it's important to think about economics, right, and where you want to run your workload. Just to show you an example, to give you some kind of bandwidth, right? What kind of figures or what kind of savings can you accomplish? Now, okay, obviously this is an Oracle versus Amazon example, but as Juan Carlos said, really depending on the service that you choose, one vendor or another might be very interesting to run, right? So in this case, just comparing apples with apples, compute power. So you can save up in the range of 50 to 70%, right? By choosing, in this case, Oracle over Amazon. But also, if you look at a company like Zoom, right, that we're using right now, they move workloads as well to Oracle because, for example, in this case, we don't charge for certain network traffic, which realize savings up to 10 times, right? So just to give you a flavor of, the magnitude of savings you can realize and why it's important to control this economics. Now, Juan Carlos, we talked a little bit about multi-cloud and benefits and why you should do it, but the question immediately pops up, right? So is this simple to realize?
That's it. As engineers, as we mentioned at the very beginning, we like to see things working. So what about integrations? Because if I have some stuff running in Azure and I want to run some stuff in Google Cloud and I want to talk to them in a consistent and reliable way from a networking perspective, how would we build the integrations? What about latencies? I mean, latency is something which is really sensitive depending on the workload. What about security? So what about governance model? What about access management? What about even contract management? So like dealing with different sales teams, different salespeople, also different bills. So there's, these questions leads to a broader one, which is like, is it even feasible? Like a multi-cloud implementation? Well, the reality is yes, it's feasible. Otherwise, we won't be here. But we're going to show a little bit later on we're going to discuss about the requirements, how to make this work, different stones that we've been facing during whatever cloud implementation, multi-cloud implementation, in order to, for you attendees, take advantage of what we've experienced with our customers.
So what are the high-level requirements to make it work right as a company? Talk us through that.
We could say high-level requirements. First of all, is to have a little bit of experience. And we know that one of the biggest advantages of the cloud is like, okay, well, everything is as a service and it's really self-service. So I'm as a developer, I've never worked in a data center before. So if you ask me, probably most of the people here in the attendees, to go to a data center, bring the rack, all the power supply, all the wiring, etc., that could take time. It will probably be able to do it, but it will be longer than already an expert, if it's an expert doing it. So, but we are smart enough to bring a virtual machine up or bring to a storage up in whatever cloud provider. So the first of all is to have some little bit of experience of using the different providers. And also the good news on this area is that most of the providers, the hyperscale providers, are offering free certification for basic usage of the platforms. Like, okay, this is the console, this is the UI, this is the CLI, this is how you provision a VM, this is how you provision the networking resources, and so forth. Or also you can contact specialized partners that have already experience in multi-cloud that can help you to accelerate. We're going to show an example later on at the very end of the presentation. The networking piece is a strong pillar. So how do we connect the different clouds in a fast and also reliable and secure way? Because you can do a remote call to an API, but that doesn't really mean multi-cloud. But what if I have the application layer or the front end running in one cloud, but the database is running in another? So I need latencies to be as consistent as the latency I need it to be as low as possible. So networking carriers is a strong point or a strong pillar in whatever cloud implementation. We're going to mention later on different networking carriers. Multi-cloud management solutions as well, because as we mentioned before, we may have our different vendors or our different cloud targets growing and growing. So having a tool to control what we have deployed and what were we using from the different vendors is going to be a hot topic for the following months and years. So keep an eye on this subject, because there are already some tools, but we haven't seen a clear leader yet in this area. So I would suggest to have a look on this area, on this topic, and who knows, maybe build your own multi-cloud management solution and open source it, which will be also key in for the following years. Highly automated workload deployment. So everything that we can automate, the better it is. There are tools like Jenkins, Docker, Terraform, we're going to discuss later, that allows that are compatible with most of the providers. So having mastered these tools and have a knowledge about how to use those tools will lead faster to a multi-cloud implementation faster. Cloud economics, as we mentioned before, vendors may evolve over time, and also leverage vendor partnerships, picking technology that is available in every provider as well. So that's something that could free the team up about choosing what technology they want to take into account. So in terms of networking, we have different setups. The first one is do it yourself. We have customers that they have their own routers in colocation with whatever cloud provider, and they build all the networking setup with different cloud providers, so without having a networking carrier. If you have the expertise, it's cool because you have control over everything in the networking side, basically. But we've seen that most of the implementations have been going for a third-party carrier. Some of them, or at least we've seen the most, are Abriatrix, Megaport, and Equinix, that they offer some kind of SaaS solution where you can connect. For instance, I want to connect this VPC, which is in Google Cloud, through this physical router, through this direct connect to AWS using this VPC and using all this data. So, and it performs all the connectivity between them. What about DNS as well? Because this is one of the strongest stones we've faced in whatever multi-cloud implementation. We basically need some kind of hybrid DNS solution. We have it documented as well in Oracle for those who want to have a look, which is basically to perform some kind of DNS forward setup in order to forward requests to the main DNS server. And now, which is also a hot topic, because we've been discussing networking carriers, VPCs, virtual circuits, and so forth and so on. But what if clouds could natively connect? Because we want things as simple as possible. The more native stuff we could use, the better it is. So what if clouds could natively connect? Arno, what do you think?
Yes, this is an interesting topic, Juan Carlos. So if you keep an eye on the news and what you will see happening over the coming years, more and more and more, is all kinds of partnerships, right, between cloud providers, because they also understand they have to work together in an ecosystem. I think yesterday Google announced a partnership with VMware, and not so long ago, almost a year ago, actually, Microsoft and Oracle announced this partnership to connect basically the two clouds together via the native cloud interface, because the networking connectivity that Juan Carlos discussed very briefly, it still requires intervention by a third party, right? You need to do all kinds of deep technical stuff to set the connection. But for example, with this partnership announcement, you have, let's say, native integration from both interfaces, so both from Microsoft, Azure, as from Oracle perspective, to set up the network connection between the two network compartments on both sides, right? With really one click of the button, like deploying a virtual machine. So no intervention of third-party network providers is needed, and it's provisioned really rapidly. But the integration also goes further in the area of identity and access management, where you can automatically connect something like Azure Active Directory with Oracle Identity and Access Management, which is built into the cloud. So you can see already a deep level of integration there. This is just only the beginning, as cloud vendors all around the world start building native integration with their competitors, because that's really what customers are asking for. Okay, so Juan Carlos, before we dive into some of the examples, right, that we see in the wild, so to say, can you talk us through a little bit about, at this moment, what is the most common set of tools and technology that we see in our customers' cloud, multi-cloud architectures?
Mm-hmm. Yeah, as we mentioned before, and also answering one of the questions that has come up on the chat, what we see in customers is like containerized applications. It's not a must, but it's something that it really helps in order to try avoiding that vendor logging, which we mentioned at the very beginning. Docker or containers, something that has allowed to developers is, or at least to companies and teams, is to avoid that it works on my machine scenario, which is like, okay, I develop something, I push it to a pipeline, and then it goes to it passes all the tests, but then once it goes to production, something crashes. So it's like, okay, it's not a development problem because it works in my machine. But yeah, we know that configurations on the development machine or the development stages against the production state, they're not the same never, or at least in the traditional world. Now that Docker or containers allow in a really, really interesting manner is that the same piece of software you're developing in your machine will be the same one, exactly the same one that will be running in production. That helps a lot. So if it allows that portability between different stages in the development process, why not between cloud providers as well? Because it also lowers the efforts in the migration. So if at some point, I don't know, AWS raises the prices for the same for the workload we're running, if we're using Docker or whatever container technology, I should be able to move that lower effort than migrating a virtual VM, a virtual machine, for instance. And that's something, so it's not a must, but it's something that we commonly see as an adoption. And even more, there's almost no hyperscale provider that doesn't offer some kind of Docker or Kubernetes service in order to use these kind of technologies, which are at least the most common ones we've seen in customers. We have customers running Mesos and running other container technologies as well, but Docker and Kubernetes are the ones that we've seen the most. Then in terms of provisioning infrastructure, as we mentioned before, Ansible, Terraform from HashiCorp Suite, most of them are compatible with most of the cloud providers, the hyperscale cloud providers. So if you're using these tools, you're probably set up better for to implement or to embrace a multi-cloud strategy in the longer term. So next slide, please.
Yep, let's move on to some real world examples.
Yep, there's Docker.
So that's the last part of our presentation. So just for Juan Carlos, we're at 21 minutes. So my first example is a company that has built image processing software for healthcare institutions like hospitals. So with that software, they can process and store and retrieve and archive radiologic images from patients. And they recently moved to a multi-cloud architecture where you see a snapshot of this architecture. Obviously, we cannot go into full details in this very short session. But basically what you see in blue is the front-end application built in .NET, which is deployed on Azure. And because this customer had a long relationship with Oracle, especially for the database backend, they really wanted to have the same kind of performance and high availability that we can provide in a RAC cluster, but then deployed on our cloud. So they built basically the connections between the front end and the back end across two clouds. So the first question you obviously ask is, okay, yeah, but what about latency between front end and back end, right? Is that really a problem, Juan Carlos?
Mm-hmm. Not really. In EMEA, or at least in Europe, we have 2 to 3 regions that are natively connected to Azure. The first one in London was the first one that was available in Europe. The ping latency between Azure and OCI, it's below 1.5 milliseconds. In that link that we had, that is underneath, we show how we measured all and also the configuration a little bit. But you can find those kind of latencies, which are pretty the same between clouds, given the fact that it's a single unit. You have first front end in Azure, and then the database is in OCI. In Amsterdam, pings are below 4 milliseconds as well, which is pretty decent and pretty nice. Yeah. Then we have another case, which is from a travel and tourism sector that is running Google Cloud, in this case, Google Cloud and Oracle Cloud as well. This is running the main transactional workload. So every time you do a booking in their platform for your holidays, it goes through this multi-cloud architecture. So the front end, it's built on GCP in Google Cloud using the Google Kubernetes engine. But then the backend, it's on an Oracle Exadata Cloud Service, okay, for two main purposes, which is the high availability and disaster recovery, using the different availability domains, which is the equivalent of availability zones. And we mentioned this because as well, why Oracle in this case? It's kind of simple. They were using Oracle at the very beginning. They could use SpannerDB, for instance, in Google Cloud, but the migration effort to migrate all the Oracle technology they have for a long time to SpannerDB could take ages. And it's a huge effort, okay? So in that sense, in order to comply also with the business purposes of being live faster, using Oracle database services and connecting both clouds were the solution in order to succeed with the timings, so the go-to-market timings they have inside a company. And also another thing, Exadata as a service, it's only available in the Oracle Cloud. So as long as they can scale in they receiving more workload for seasonal reasons, for instance. So as long as they increase the number of containers and pods on Google's cloud side, we can scale our databases with no downtime as well. So we can respond to the front-end workload with no downtime, which is pretty decent. And the latency we experience, in this case in Frankfurt, between GCP and OCI, it's around 1 millisecond, which is pretty nice for being different cloud providers as well.
Okay, and what about SaaS and IaaS PaaS integration?
That's correct. This case is a home emergency repairs company. They're using Salesforce for CRM, and also they're using a different Oracle service for budgeting and quoting purposes. But so the integration services have been in Oracle, plus some other applications on top of Kubernetes, which are intended for SaaS extensions for both Salesforce, Oracle's, and also some other custom applications for internal purposes as well inside the company. So using these integration services, with all the connectors, catalogs, and some other features that these services has, it reduces complexity and increases the agility. Low latency between the different clouds makes the user experience better as well. So the business users that are using Salesforce for whatever reason, they see almost no time in loading data or loading the different screens for the application that is running in a different cloud providers. And also another of the reasons for using Docker and Kubernetes applications for different purposes is like, okay, they might be running those applications in Oracle services, but at some point, if they want to move them to Azure, because Azure has a very good offer for them, or for whatever business reason, they can port that application with low effort in that sense.
Okay. Now, last slide before we finish this presentation, right? We talked about the economics of different clouds, right? Running your workload on different clouds. But there could also be a driver that people would like to run their own open source stack for Kubernetes or to run their container applications, and do not want to buy into some kind of managed services. So this is a nice example from a company called Midships. They are in the market to really help other companies to accelerate the migration to cloud and to multi-cloud kind of solutions. Right, but the interesting point here is that if you want to go to a cloud native environment, right, and quickly start to take your legacy applications and move them to container-based kind of architecture, you can do this with this product, right? And the nice thing about this is that if you deploy this, it's not only ultra fast to deploy, but right, you have Kubernetes environments and clusters running on Microsoft and on Oracle Cloud. So you can determine, okay, spin up a couple of more containers here because it's cheaper today, and tomorrow we do the reverse, right? Because we get a better offer. But also in terms of super high availability. So you imagine that there is some kind of outage with Azure or Oracle. I hope not, but in case it happens, you don't have to go in some kind of panic mode because you can simply launch that workload that day in the available public cloud, let's say. So that's the last example. Unfortunately, we're out of time. It was a pleasure to be here today. This was really the top of the iceberg of what we could talk about, and we could go into much more depth. Now, also, so if you want to know more about multi-cloud, or you want to just discuss these kind of architectures or how to do it, feel free to drop us an email or reach out to the Jay on the Beach organization. And last but not least, we've also started, let's say, a vendor independent multi-cloud community, right? Where we aim to bring together really experts from different cloud worlds together, right? To form a little expert network where you can ask your questions and where you get updates once per month. So if you're interested in that, visit multicloud.fans and let us know what your needs are in this area. I'm more than happy to help. Okay, that's it from our side. I hope you enjoyed it, and looking forward to to speak with as many of you out there as possible. Thank you. Have a nice day.
Thank you very much.